Next topic is Biot-Savart's law. Here you have to just consider a conductor. Let I be the current flowing through the conductor. When we pass current through a conductor, a magnetic field can be produced as concentric circles around the conductor. So that to find the magnetic field, we have to just consider a point P. And the distance between the point P to the conductor, which is taken as R. So around this point, we have to take a smallest element. The length of the smallest element, which is taken as dl. Let theta be the angle between the current carrying conductor and the line joining the midpoint of the current element. So here the magnetic field intensity at the point P due to this smallest element, which is directly proportional to the strength of current, the length of the element and sine of the angle theta, and it is inversely proportional to the square of distance between the point and the element. To remove this proportionality, we have to introduce a constant. The constant is K. So dV is equal to K into I dl sine theta by R square. The value of this constant, which is equal to mu 0 by 4 pi. Mu 0 is said to be the permeability of free space. The value of this mu 0, which is equal to 4 pi into 10 raised to minus 7. The unit of this constant is Newton per ampere square. If we substitute the value of K in this equation, we can write dV is equal to mu 0 by 4 pi I dl sine theta by R square. This is the equation to calculate the magnetic field. In vector form, we have to represent this equation as d vector dV is equal to mu 0 I dl cross r cap the whole divided by 4 pi r square. Or we have to represent the same equation by vector dV is equal to mu 0 I vector dl cross vector r the whole divided by 4 pi r cube. If you are using unit vector here, denominator you can just write r square. But at the same time, if you are using vector r, the denominator we have to use 4 pi r cube.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.